Okay, looking at 3.2 absolute value graphs, practice problems today. Looks like the first three here, we just need to list the range of these absolute value equations. So we can go ahead and first start out by just graphing them out. Looks like our slope is 1, and our vertex, remember, it's h comma k, and h is the opposite, right? So our vertex is going to be 3, negative 4. Okay, so we're going to go over 3, down 4. It's right there. And we've got a slope of 1, so we're just going up 1 over 1. And in the opposite direction as well. So there we go. Here's the graph. So now we need to list the range here. So y is, what's the lowest value of y in terms of the y-axis, which is right here, right? The lowest we can go is here, and that is at negative 4. Okay, so y just has to be greater than negative 4 because there's no max value, because these are arrows, meaning they go on forever and ever. Okay, I'll do one more. Number 2, the f of x is equal to 3/4. Okay, so there's our slope. Okay, and our vertex, remember, it's going to be the opposite of here, of this number. So this can be negative 2, negative 1. This is our h, this is our k, and the h is it's the opposite of the h, right? Or negative h. Okay, so we're going to go back 2, down 1. So there is our vertex, and then we're going up 3 over 4. 1, 2, 3 over 1, 2, 3, 4. And we're going to go for, here's like, this is like the axis of symmetry here. So if we were 4 away going to the right, we're going to go 1, 2, 3, 4 in the other direction. And here is this function, like that. And our range, it looks like, again, there isn't going to be a max value because the arrows, meaning these go on forever and ever. But what's the lowest value or the minimum value? It's going to be right here at y, negative 1. So y just has to be greater than or equal to negative 1. Okay, you guys can do the range for this one. I'll give you guys, here's your slope, your hk, or your vertex, right? It's going to be the opposite of h, right? So it's going to be 1, and then there's nothing out here, so that's 0. Okay, so here's your vertex, 1, 0. That's right there. Your slope is negative 3 over 1, so we're going to go down 1, 2, 3 over 1, both directions. There is, ooh, gosh, that was bad. There is our function. You go ahead and put the range on there. All right, number 4 through 9, we're just graphing out these inequalities. So here we're going to plot this out just like a regular line. We're going to start on the y-intercept of negative 1, and we're going to be going down 2 over 1. We can also go up 2 over 1. So here is our line. We have to determine if it's solid or dashed. There's no line underneath, so that means it is going to be a dashed line. Okay, and this is less than, so we go below. Less than, we shade below. There we go. All right, number 5, y is greater than or equal to 4. So if this were just y is equal to 4, that would be a line. Where's 4 at? Right here. That would just be a horizontal line like that, but it's an inequality. The line is underneath, so it should be a solid line, not dashed, and it's greater than, so we shade above. Okay. All right, we need to isolate for y here, so we need to subtract 2x, subtract 2x. I'm going to write this over here. negative 3y is equal to negative 2x minus 9. I just swapped the order here, so that's the way it should be written. Now I divide by negative 3, divide by negative, ooh, whoops, I got an equal sign there. Let's just start this one over. Negative 3, I can't even write today. Negative 3y is less than or equal to negative, struggling here, guys. Negative 3y is less than or equal to negative 2x minus 9. Now we want to divide by negative 3, divide by negative 3. Yeah. But if we are dividing by a negative to solve, we need to switch the sign. So that we're going to make that a greater than or equal to sign. Negative 2 over negative 3, we are going to keep that as a fraction, but we need to recognize that that will be positive. And negative 9 over negative 3 is positive 3. I'll leave the rest for you guys. You can go ahead and plot that out and shade in where you think it needs to be shaded. Number 7, 8, and 9, we have some absolute value inequalities. Okay, so let's, of course, we start by finding the vertex, right? The vertex is HK. All right, well, there's nothing inside to the right of the X, right? That value, that H value isn't there, so the H value here is going to be 0, negative 4. This is your K value. So there is our vertex at 0, negative 4. So we're just going to go down 4 on the y-axis. There is our vertex, and our slope is going to be 2 over 1. So we're going to go up 2 over 1. Up 2 over 1, and we can go opposite direction as well. All right, so here is our function. Now, do we want to have this solid lines or dashed? Here's the line underneath, so it's going to be solid. So we're going to go, it's going to be going this way. And y is greater than, so we're going to shade above. So above would be here. All up there too. Okay. All right, number 8. Start with the vertex. Negative 2, 1. Right? Opposite of this h value. K is straightforward. So negative 2, 1 over 2, up 1, right there. It is the a value is not there, so that's 1. So we're just going up 1 over 1. So it looks like it's going to be like that. Oh, but I went a little bit too fast. I'll just put the points out there. Okay. There's the points. Now we should determine the line, which I was getting a little bit ahead of myself. There is no line underneath there, so that means it goes all the way up to this line, but it does not include it. So we're going to make this a dashed line. Okay, and the f of x is less than, so we shade below. Okay, you guys can do number 9. Remember, start with the vertex. Okay, now we're going to be writing out our equations. Okay, so we can use the f of x or we can use y. Looks like these are going to be equations because there's no shading, right? So this is going to be equals, so that's good, right? There's no shading, so this is not an inequality. So let's leave some room for our slope. Let's leave room for our h value and our k value. So we can start with that. And now let's look at our vertex, which is right here, which is at point 2, 3. And so remember, this is always the opposite inside these absolute value bars. So this is negative 2, and then this one, the k value, is off to the side on the outside of the absolute value, positive 3. And now we can look for our slope. So it looks like the next point it hits perfectly is right here. So we're going to be going down 2, over 3. So this is going to be, the slope is going to be 2 over 3. And is this a negative or positive slope? Well, it is an upside down V, right? So this is going to be negative. Okay. Number 11, we can start a similar way, right? Y is equal to, give some space for the slope, space for the H value inside, and then we look at the vertex. Vertex is right here at -1, -4. HK, H is the opposite, so it's going in as +1, -4 off to the side, and then we look for the slope, which is going to be up 4 over 1. So we can just put this as 4. And it is positive, right? This is a upwards V, so it's positive. Okay? All right, why don't you guys try number 12? Just remember the H value is at 0, so we don't really need to even include it inside there. Okay? You guys can try 12. Now let's look at some of these inequalities. So these ones here are just linear inequalities, so we can just start with those. We're going to have y is, let's leave some, well, let's just fill it in like this. Here's our y-intercept. Okay. Okay, and then our slope, let's see, we're going here, not quite there. Looks like it's hitting pretty perfectly right there, which is going to be up 3 over 4. Okay, so there is our slope. M value is going to be 3 over 4. So this one is going to be, let's just write this off to the side first. 3 over 4x minus 2. And then let's look. Okay, so it's a solid line, right? Okay, so the line's going to be underneath, and it is shaded below, so then y must be less than. So there we go. And then last part here, is 3, 0 a part of the solution? Where's that at? 3, 0 is right here. That's inside the shading, so this would be a yes. Okay. All right, next one here. This is just going to be x and -2. And this is shaded to the left, so this is going to be less than or equal to, because it's a solid line, right? Because anything that over here is smaller than -2. Okay. And is -3, or sorry, -1, -3 a solution? -1, -3 is right here, which is not inside the shading, so this one is no. All right, you guys can do number 15. I think I want to give you guys a few of these to do on your own, so I'm going to do number 18 for you guys. Okay. So let's start with y. Leave some room for the absolute value, or for the inequality symbol and the slope. So I'll set this out here. Okay. So let's start with our vertex, which is right here at point 2, -3. Okay. HK. H is the opposite, so it goes inside here is -2. K is -3. And what's our slope? Okay, so now let's look at our slope. Okay, it looks like, okay, it's just a 1-to-1 relationship, so our slope is just going to be 1, so we don't really need to write anything there. Now we can just look at our inequality symbol. So it is a dashed line, so there's not going to be a line underneath. Okay, and it is below, it's shaded below, so y is going to be less than. There we go. That's it. Last part Is negative 3, positive 1 a solution? Well, negative 3, positive 1 is right here, which is in the shading, so this is a yes. All right. Why don't you guys give the rest a shot? If you need more help, you know where to find me. Good luck.